Imagine going very far from our home planet. Imagine going past the moon. Out there, in the huge space, you'll see something small and blue. It's Earth, where we all live. But from so far away, it looks tiny. Within that tiny dot called Earth, there exists an incredible wealth of life and history. Inside our tiny Earth, there's a whole lot going on. Just think about everyone you've ever met, everyone who has ever lived, and all the stories ever told. Now they're all crammed into this little speck floating in space. Now, if we were to compare ourselves to the enormity of the universe, we'd be like tiny grains of sand on a never-ending beach. It's kind of humbling, isn't it? But despite our small size in the grand scheme of things, each of us has our own stories, feelings, and connections that make us unique. Even though the universe is mind-bogglingly big, every little thing we do here on Earth matters. Our actions, no matter how small they may seem, have the power to change the world around us. So, even though we're just tiny specks in the universe, we still have the ability to make a big impact. But there's something mysterious about our universe. What secrets does universe have? What interesting things are hidden there? Let's explore and find out. Are you excited to learn about the secrets of our own universe? Welcome to the beginning of our adventure. We're leaving behind the familiar comforts of Earth to embark on an extraordinary journey. Our mission? To explore the vastness of the universe and unravel its mysteries. Our first stop on this cosmic journey is the Moon, located about 384,000 kilometers away from Earth. To put this distance into perspective, imagine driving a car at a steady speed of 100 kilometers per hour. It would take you over 160 days to reach the Moon. From the perspective of the Moon, Earth looks like a fragile ball with beautiful shades of blue and green. It stands out against the vast darkness of space, creating a mesmerizing sight that makes us feel small and amazed by the grandeur of the universe. Look at Earth from the Moon. It's a sight that makes us think about how beautiful and delicate our planet is, seen from a viewpoint we can hardly imagine. Are you excited to keep going and discover what's out there? As we press onward in our cosmic voyage, our next destination is the mighty Sun, located approximately 1 astronomical unit away from Earth. This unit, equal to about 150 million kilometers, serves as the standard measurement for distances within our solar system. Picture this. Light, traveling at an astonishing speed of 300,000 kilometers per second, takes around 8 minutes and 20 seconds to make the journey from the Sun to Earth. If we were to attempt this journey in a commercial jet flying at a speed of 900 kilometers per hour, it would take us about 19 years to reach our destination. This huge gap reminds us how big space is, even just in our own solar system. When we think about the vastness of the universe, we realize how small we are. Now, are you ready to explore more of space with me? The Sun, a big burning star, gives our planet the energy it needs for life. But now, let's go farther, past Earth and its hot buddy, the Sun. Our next stop, Mars, the mysterious red planet. Mars can be as close as 54.6 million kilometers to Earth. But when they're on opposite sides of the Sun, the distance stretches to a whopping 401 million kilometers. To understand just how vast that is, imagine this. If you traveled to Mars at the speed of a regular plane, it would take you over 50 years to get there. That's why exploring Mars has been such a big challenge for us. As we journey to the outer edges of our solar system, we encounter Neptune, a remote ice giant situated drolly 4.5 billion kilometers away from Earth. The rovers and probes that we've sent to explore Mars have a tough journey ahead of them. It's not easy because the distances keep changing, and the way planets move around the Sun can be tricky to navigate. Sunlight, traveling through the vacuum of space, takes about 4 hours and 15 minutes to reach Neptune from the Sun. Neptune serves as a significant boundary, marking the outer limits of our solar system's influence. The Voyager 1 space probe, launched in 1977, symbolizes humanity's insatiable curiosity and our desire to explore the cosmos. Voyager 1 has gone farther than we ever thought possible, journeying for over 4 decades and covering an incredible distance of more than 22 billion kilometers from Earth.
For nearly 35 years, NASA's Voyager 1 probe has been hurtling toward the edge of the solar system, flying through the dark void on a mission unlike anything attempted before. One day, Mission controllers hope Voyager 1 will leave the solar system behind and enter the realm of the stars, interstellar space. That day may be upon us. The latest data from Voyager 1 indicate that we are clearly in a new region where things are changing quickly, says Ed Stone, Voyager project scientist at the California Institute of Technology in Pasadena. This is very exciting. We are approaching the solar system's final frontier. The frontier he's referring to is the edge of the heliosphere, a great magnetic bubble that surrounds the sun and planets. The heliosphere is the sun's own magnetic field, inflated to gargantuan proportions by the solar wind. Inside lies the solar system, home. Outside lies interstellar space, where no spacecraft has gone before. A telltale sign of the frontier's approach is the number of cosmic rays hitting Voyager 1. Cosmic rays are high-energy particles such as protons and helium nuclei, accelerated to near-light speed by distant supernovae and black holes. The heliosphere protects the solar system from these subatomic bullets, deflecting and slowing many of them before they can reach the inner planets. As Voyager approaches the frontier, the number of cosmic rays has gone up. From January 2009 to January 2012, there had been a gradual increase of about 25% in the amount of galactic cosmic rays Voyager was encountering, says Stone. More recently, however, we have seen a very rapid escalation in that part of the energy spectrum. Beginning on May 7, 2012, the cosmic ray hits have increased 5% in a week and 9% in a month. The sharp increase means that Voyager 1 could be on the verge of a breakthrough, 18 billion kilometers from Earth. When Voyager 1 actually exits the heliosphere, researchers expect to see other changes as well. For one thing, energetic particles from the sun will become scarce as the spacecraft leaves the heliosphere behind. Also, the magnetic field around Voyager 1 will change direction, from that of the sun's magnetic field to that of the new and unexplored magnetism of interstellar space. So far, neither of these things has happened. Nevertheless, the sudden increase in cosmic rays suggests it won't be long. Meanwhile, Voyager 2 is making its own dash for the stars, but because of its slower pace, lags a few billion kilometers behind Voyager 1. Both spacecraft remain in good health.
It's the farthest thing humans have ever made from our planet. In 1990, Voyager 1 did something remarkable. At the suggestion of the famous astronomer Carl Sagan, it turned its camera back towards Earth and took a picture.
We are star stuff. What he meant is the key elements of life were forged in the hearts of stars. The iron that turns our blood red, the oxygen that fills our lungs, the carbon that gives infinite variety to organic compounds, they were all cooked up in a stellar inferno billions of years ago. So, when researchers recently got a look at a star turned inside out, they knew they were looking at the stuff of life itself. The story begins just after the Big Bang 13.7 billion years ago. According to modern cosmology, the newborn universe was made entirely of the three simplest atoms: hydrogen, helium, and small amounts of lithium. The cosmos was devoid of stars and very likely devoid of life as well. A quick glance around the room is proof that times have changed. Light elements that filled the early universe are rare on Earth, while our planet and we ourselves consist mainly of heavier stuff like oxygen and carbon, which were missing at the dawn of cosmic history. The difference is star formation. A little more than 13 billion years ago, the first stars collapsed from clouds of hydrogen and helium. As gravity drew the gas inward, temperatures reached levels that triggered nuclear fusion, the same process that powers our sun today. In a stellar fusion reactor, hydrogen and helium are smashed together to build up heavier elements, such as carbon, nitrogen, oxygen, and iron. Since then, heavy elements have been forming in stars throughout the universe. Supernova explosions presumably did the rest, flinging their contents far and wide, seeding galaxies with the atomic building blocks of life. Recent data from NASA's Chandra X-ray Observatory provide dramatic confirmation for this idea. Researchers Una Huang of the Goddard Space Flight Center and John Lamming of the Naval Research Laboratory used Chandra to map elements in the debris of a supernova known as Cassiopeia A, Cas-A for short. Cas-A is located about 11,000 light-years from Earth. The original star, a behemoth at least 15 times as massive as the Sun, exploded more than 300 years ago. Hot, glowing debris from the explosion is still visible and a favorite target of astronomers who study supernovas. The researchers scanned Cas-A using Chandra's advanced CCD imaging spectrometer. This revealed concentrations of iron, sulfur, silicon, magnesium, neon, and oxygen. Comparing a chemical model of the original star to the actual distribution of elements seen today, they realized something amazing. When the star exploded, it turned itself inside out. Most of the iron, which originally formed deep inside of the star, is now located near the outer edges of the debris cloud. Other heavy elements are also located at the outer limits of the debris zone. These data show that elements cooked deep inside stars are not necessarily trapped inside. Supernova explosions can free them, spewing core materials into deep space. There, the atoms of life intermingle with other interstellar atoms and molecules, forming clouds of gas that collapse to form new stars, new planets, and maybe, just maybe, new life forms. We are star stuff, after all.
What it captured became known as the pale blue dot image. From a distance of about 6 billion kilometers away, our planet looked like a tiny, faint dot in the vastness of space. Sagan poetically talked about this image, reminding us of our duty to love and protect our only home, Atney speck in the huge universe. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner, how frequent their misunderstandings, how eager they are to kill one another. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Oort Cloud is like a giant storage unit at the edge of our solar system, filled with icy objects. It's so far away that it's about 100,000 times farther from the Sun than Earth is, which is roughly 1.9 light-years away. That's really, really far. It's almost like the starting point of the space between stars. At the heliopause, our solar system sort of comes to an end, and we start to enter the vast space between stars.
Exactly like what we find here at home, says David McComas, the principal investigator for IBEX at the Southwest Research Institute in San Antonio, Texas. Our solar system is surrounded by a magnetic bubble called the heliosphere that separates us from the rest of the Milky Way. Outside the heliosphere lies the realm of the stars, or interstellar space. Inside lies the sun and all the planets. The sun blows this vast magnetic bubble using the solar wind to inflate the sun's own magnetic field. It's a good thing. The heliosphere helps protect us from cosmic rays that would otherwise penetrate the solar system. Launched in 2008, the IBEX spacecraft spins in Earth's orbit, scanning the entire sky. IBEX's special trick is detecting neutral atoms that slip through the heliosphere's magnetic defenses. Without actually exiting the solar system, IBEX is able to sample the galaxy outside. The first 2 years of counting these alien atoms have led to some interesting conclusions. We've directly measured 4 separate types of atoms from interstellar space, and the composition just doesn't match up with what we see in the solar system, says Eric Christian, mission scientist for IBEX at NASA's Goddard Space Flight Center in Greenbelt, Maryland. In a series of 6 science papers appearing in the Astrophysical Journal, the IBEX team reported that for every 20 neon atoms in the galactic wind, there are 74 oxygen atoms. In our own solar system, however, for every 20 neon atoms, there are 111 oxygen atoms. That translates to more oxygen in any given slice of the solar system than in local interstellar space. Where did the extra oxygen come from? There are at least 2 possibilities, says McComas. Either the solar system evolved in a separate, more oxygen-rich part of the galaxy than where we currently reside, or a great deal of critical, life-giving oxygen lies trapped in interstellar dust grains or ices, unable to move freely throughout space, and thus undetectable by IBEX. Either way, this affects scientific models of how our solar system and life formed. It's a real puzzle. While IBEX samples alien atoms from Earth's orbit, NASA's Voyager spacecraft have been traveling to the edge of the heliosphere for nearly 40 years, and they could soon find themselves on the outside looking in. Researchers expect Voyager 1 to exit the solar system within the next few years. The new data from IBEX suggests the Voyager...
This is where the sun's power stops, because it meets the stuff that's between stars. It's like a boundary line where our solar neighborhood ends and the wide open expanse of interstellar space begins. When we talk about begins the cloud, we're talking about the start of the outermost part of our solar system. It's like the beginning of a journey into space beyond what we know about our own solar system. Our next destination is Alpha Centauri, the nearest star system to our Sun, located approximately 41.3 trillion kilometers away. That's more than 276,000 times the distance from Earth to the Sun. When we're dealing with such immense distances, the standard unit we use within our solar system, called the astronomical unit, isn't very useful anymore. Instead, astronomers rely on the light year, which is the distance light travels in 1 year to measure these vast spaces between stars. Considering the technology we have today, traveling to Alpha Centauri seems nearly impossible. Even if we were to send the Voyager spacecraft, one of the fastest objects humanity has ever created, zooming along at about 17 kilometers per second, it would still take more than 70,000 years to reach Alpha Centauri. This demonstrates just how incredibly far away other stars are and how daunting it is to traverse the distances between them. Continuing our journey, we'll soon encounter the immense expanse of our home galaxy, the Milky Way. Stretching approximately 100,000 light-years in diameter, this colossal spiral galaxy resembles a bustling city of stars, with hundreds of billions of them sparkling across its spiral arms. Each of these stars holds the potential to harbor its own planetary systems, raising the exciting possibility of life existing beyond our own planet. Inside this immense galaxy, there's a small area known as the human radio bubble. It spans around 100 light-years from Earth and marks the farthest reach of human influence in space. Beyond this bubble, our radio and television signals weaken and disappear into the vast expanse of the cosmos. It's like a barrier beyond which our existence is unknown to any civilizations inhabiting the rest of our galaxy, as our signals haven't reached them yet. The Milky Way is so gigantic that our entire history seems insignificant in comparison, like a faint whisper lost in the vastness of space. Once we venture beyond the Milky Way, we step into the immense and unfathomable expanse known as intergalactic space, where the universe's secrets await discovery. Out in this vast universe, there are countless galaxies drifting about. They're incredibly distant from each other, making their true scale hard for us to grasp. One such group of galaxies is called the local group. It's like a small neighborhood in space, with over 50 galaxies mingling together. Some are large spirals, resembling our own Milky Way, while others are smaller and known as dwarf galaxies. The distances between these galaxies are mind-blowing. It would take light, the fastest thing we know, 10 million years to travel from one end of the local group to the other. That's way bigger than anything we see in our own galaxy. It shows us just how massive the universe is and where we fit into it. Out here, in the quiet spaces between galaxies, there's no noise, just silence. And in this vast emptiness, our galaxy is just a tiny dot among lots of others, like one small story in a huge book about the universe. As we travel far from our galaxy, we find something amazing, the Virgo supercluster. This supercluster is massive, about 110 million light-years wide, with thousands of galaxies, each with its own stars and planets. But there's something even bigger out there, the Laniakea supercluster. It's like our cosmic home on a huge scale, with galaxies stretching over 500 million light-years. This supercluster is so big, it's hard to imagine, with a mass equal to 100 million billion planets. In the vastness of space, there are many secrets waiting to be discovered. We're on a journey to explore these mysteries and learn more about the universe. Think of the universe as a giant puzzle. It's made up of galaxies, clusters, and superclusters, all fitting together like pieces in a puzzle. Our Milky Way galaxy, along with other galaxies, is just a small part of this big picture. There's a force called the Great Attractor that pulls everything towards it, including our galaxy and many others. Even though the universe is huge, we can only see a small part of it. This part is called the observable universe, and it's about 93 billion light-years wide. That's a long way. But here's the tricky part. The universe is much older than it looks. It's been expanding since the Big Bang, like blowing up a balloon. So even though it started small, it's been growing bigger and bigger over time. But what's beyond what we can see? Some parts of space are moving away from us so fast that we can't see them anymore. They're beyond our reach, no matter how hard we try to look. This means there's a lot we still don't know about the universe. So, even though we've learned a lot about space, there's still so much more to discover. The universe is full of mysteries waiting to be uncovered, and we're excited to keep exploring and learning more about it. In the huge expanse of space, with galaxies swirling and stars twinkling, we see ourselves as tiny dots in the big plan of the universe. As we travel through space and discover its wonders, we're reminded of how special our home, Earth, really is. Earth is like a precious gem among the endless cosmos, a place where life thrives in harmony. But as we admire the beauty of the universe, we realize that the real treasure isn't what we own, but how we take care of our planet and each other. In this vast universe, full of wonders we can't even imagine, we're just passengers on a big journey through space. Our lives, our accomplishments, and our belongings may seem small compared to the grandeur of the cosmos. It's a reminder of how important it is for us to live together peacefully. As we explore the mysteries of the universe, let's remember the wisdom of our shared humanity. No matter our differences, we're all connected by the experience of living on this small planet. Facing the vastness of space, let's join hands as caretakers of our planet, working together to protect its beauty and diversity for the future. Let's cherish and safeguard the delicate ecosystems that support life on Earth, and strive to make a better world where everyone can thrive. In our journey through the cosmos, let's find comfort and inspiration in the teachings of religion, guiding us to show kindness, compassion, and respect for all living things. Because in the vast universe, it's our shared humanity and our efforts to care for our planet that truly give purpose to our lives. Together, let's embrace the beauty of the cosmos and the richness of our shared humanity as we work towards a brighter future for ourselves and the generations to come. Please consider subscribing, liking, and supporting us. Your support means the world to us and helps us continue creating content that we hope you love. Thank you for being part of our community.